Hi everyone. In this video, I'd like to work through some function notation review. So the big things that we're going to need throughout our exam 1 material are really good use of function notation and recognizing function notation, a really clear understanding of slope and rate of change, and really strong algebra skills. So this will hit the function notation and the algebra skills in particular, and there is actually a little bit of rate of change in the mix as well. Okay, so just on the function notation, you want to think about this whole input-output relationship. So a function relates two or more variables. You've probably mostly seen two variable functions so far, and that's what this is. You have an input variable x, and then you output f of x's, or you could call those your y's. Y is your output variable. And your function is basically a rule. It tells you how to find the value of one variable given the other variable. And it's kind of set up to give it the value of x and find the value of y, but you could do the other as well. It is possible. So here, whatever x we give this function, the function will always do the same thing. It will square it. It will subtract it from 1, and that will be your output. So it doesn't matter what I give it, that's always what it'll do. It'll give me 1 minus x squared. Okay, so if I want to find f of 1, I'm going to follow that rule. I'm going to take the 1, I'm going to square it, and I'm going to subtract it from 1. So just following my order of operations there. 1 squared is still 1, so I'm really just getting 1 minus 1, which is 0. So this tells me that function f passes through the point 1, 0. If I input 1, I output 0. That's my input-output pair. And on a graph, that's an xy pair. You should also be able to calculate the average rate of change from 0 to 3. So remember, this is just a slope. We'll need to find f of 0 and f of 3. If I plug 0 into my function, I get 1 minus 0 squared, which is 1. If I plug 3 into my function, I get 1 minus 3 squared, which is 1 minus 9, which is negative 8. So this is telling me I have the point 0, 1 and the point 3, negative 8. If I want to calculate an average rate of change from x equals 0 to x equals 3, I would do a rise over a run. So I would take f of b minus f of a over b minus a, which is giving me negative 9 over 3, which is negative 3. And again, what that's telling me about is the slope of a secant line. So if I looked at the graph of this function is a parabola. It's flipped upside down. So we take our basic x squared and the minus sign flips it upside down. And then we could think of it in the other order. We have to add 1 to that, so that shifts it up 1. So this is 1, 1, negative 1, and it's headed down like this. So if we start at x equals 0 and we stop down here at x equals 3 and we connect the dots, we're going to get this secant line, and the slope of that line is negative 3. Okay, these two are kind of a pair, and I even numbered them the same, lettered them the same. We'll pretend that was on purpose. Okay, so f of x plus 1 with the 1 outside the parentheses, and f of x plus 1 with the plus 1 inside the parentheses. These are different, and this is a really important distinction to make. So this is saying plug x into your function and then add 1 to your output. If you plug x into your function is going to square it and subtract it from 1 and give you exactly what you see at the top. That's what this says. If you plug x into the function, you get 1 minus your x squared. And then we're supposed to take that output and we're supposed to add 1 to it. Be really careful, the minus sign's only attached to the x. A lot of people want to say that the 1s go away, but they don't. They actually are 1 plus 1. They're going to leave us with 2. So I have a 2 minus x squared. Okay, not to be mistaken with f of x plus 1 where the plus 1 is in the parentheses. This is telling us to input an x plus 1 into our function. And we know what our function does. Whatever we give it, this time x plus 1, it's going to square it and subtract it from 1. So this is what we end up with. And then we need to do a little bit of careful algebra to simplify that thing. So I'm going to do this in 2 steps because a lot of people make mistakes with the minus sign. In fact, I would say that's the number one algebra mistake I see that gets people in big trouble early on in Calc 1. So first thing I'm going to do is FOIL this out. That's an x squared plus 2x plus 1. Okay, so fatal algebra mistakes, ones that I'm going to really be upset if I see. Distributing exponents, that's a really bad one. That doesn't work. Squaring something means multiplying it by itself, and that will result in a FOIL. And then not distributing negative signs is the other one. So I get a 1 minus x squared minus 2x minus 1. This time the ones do go away. When I combine that, I have a positive 1 and a negative 1, which adds up to 0. So it looks like I'm getting negative x squared minus 2x. Okay. So last part here. Here, I'm going to try and be a good example giver here. When you're doing your homework, it kind of looks like this. Circle your answer for me so I'm really clear on what you're ending up with, because I don't get a video of what you're thinking. Okay, last one, and this is an important one. F of x plus h minus f of x all over h. I don't know if you see it immediately, but I hope you'll start to. This is a difference quotient. It doesn't look quite like the one that you saw in the first video. Difference quotient. I don't know why I can't write right now. Difference quotient. Oh, goodness. Quotient. There we go. Maybe. I don't know. I'm losing my mind. Sometimes I think too much about spelling and then I can't spell. Okay, so anyways, what we see here, it might not look quite like the average rate of change, but it really is. This is like an average rate of change from x to x plus h. If you look at how that sets up, you'd get the top, f of x plus h minus f of x, and then on the bottom, you'd have x plus h minus x. And notice that those x's are going to drop out, and that's going to leave us with just the h on the bottom. So this is a different version of the difference quotient, and really what's special about this version is instead of emphasizing the fact that we've picked 2 different points, this is emphasizing 1 point, x f of x, and how far away the second point is. That's really what h is. H is the distance between the x values. H is your run. So this one emphasizes a single point and a run, and you could change the size of the run, and that would change the average rate of change. Okay, so algebraically, these are incredibly important when we finally get to finding derivatives. You're going to do tons of these. And you want to be really careful. So we have our function here. I'm just going to rewrite it right here. Our function is f of x is 1 minus x squared. So we want to do a few things. We want to find f of x plus h, which is going to be x plus h squared subtracted from 1. Sorry, I'm running into my side scribbles. Which is similarly to up above, you need to square this thing, which means you'll have to multiply by itself, and you'll get x squared, and you'll end up with 2 xh's and an h squared. And then you need to distribute in that minus sign. Okay, so there's my f of x plus h. We also need to find f of x, but that's easy. It's a 1 minus x squared. And then we need to put all of this together. So you don't really have to do this separately. And as we get more comfortable, I'll start to do it all together, but I want you to see the pieces. So if we want f of x plus h minus f of x, that's going to be a 1 minus x squared plus, oh, look at me. I lectured you about distributing minus signs, and then I didn't do it. There we go. Minus 2xh minus h squared. And then we're going to subtract off an f of x. And this is another spot where you want to be really careful about distributing your negative sign. If your difference quotient doesn't simplify nicely, the most likely problem is that you forgot to distribute a negative sign. So go back and check that. Okay, so I get 1 minus x squared minus 2xh minus h squared minus 1 plus x squared. Distribute that minus 1 through. And then nice things should eventually happen. Sometimes you have more of an algebra mess than this, but usually we get to a point where things like this happen. I have a negative x squared and a positive x squared. When I add those up, I'll get 0. I have a positive 1 and a negative 1. When I add those up, I'll get 0. And I'm left with negative 2xh minus h squared over h. And here's the really important part. When we're simplifying difference quotients, the most important thing is you want to keep simplifying until you can cancel the h out of the bottom. This h right here gives us trouble. Our goal eventually is going to plug 0 in for h, and that's why we don't want that there. So let's factor out an h. You could factor out the minus sign as well if you want to. It doesn't really matter either way to me. And then again, we get to get rid of some stuff nicely. Notice this, there's a difference here. These add up to 0, so they're gone. And here, this is h divided by h is 1, so there's no need to write that. So my final answer here is a negative 2x plus h. So here, we're kind of losing the meaning, possibly, and that's okay. The big thing here is just to practice the function notation and the algebra part, but eventually that's going to have a really specific meaning for us, and I'll even tell you now. It may or may not stick. I'll say it again later. What's happening here is this is giving us the average rate of change from a specific x value to an x value that's h units away from that. So if I, for example, wanted to know the average rate of change from 2 to 4, I would say, okay, my starting x value is 2 and my final x value is 2 away, and this would give me an average rate of change. So eventually we'll get there. All right, thanks for watching.